After 30 years of studying floods worldwide, you've come to a conclusion that there was one big flood in the past. What were the evidences that led you to that conclusion?
Plateaus, number 1. Mega valleys and canyons, number 2. Sedimentary layers, number 3. Water gaps, number 4. And underfit rivers, number 5. All of it points to a catastrophic global event, best explained by the world flood.
Ron, you're a fluvial geomorphologist, a flood expert. You've held research and teaching positions in 6 universities across the world. In Finland, Australia and China, you've held professorial positions. After 30 years of studying floods worldwide, you've come to a conclusion that there was one big flood in the past. Is that right?
That's correct. As a researcher, I travelled the world studying landforms and floods, particularly in large systems such as the Amazon drainage basin. And out of all of this, I came to the conclusion there was one flood. More importantly, it occurred only a few thousand years ago.
Okay, so what I want to do in this interview, Ron, is I want to find out what were the evidences that led you to that conclusion during your 30-year journey to discover that there was one worldwide flood. Only a few thousand years ago, as you say. What are the evidences?
There are many types of evidence, Scott. But if we can keep it to 5, that'd be great. What I'd like to speak on, if we have the time, is plateaus, number 1. Mega valleys and canyons, number 2. Sedimentary layers, number 3. Water gaps, number 4. And underfit rivers, number 5. If we have the time, I'd love to go through those.
Yes, I'd like to look at each one of those, Ron, and I want to try and understand, what did you see as a researcher in the field? What did you see, and why is that a convincing evidence? So you mentioned plateaus to start with. Now, can you tell us what is a plateau?
Well, a plateau is a sort of an elevated, fairly uniform surface. It's often called a tableland by people. And it's often dissected by steep gorges or steep cliffs, so on, around them or through them and so on. Plateaus can be thousands of square kilometres in size, actually.
Okay, and so how do plateaus indicate that a flood occurred in the past?
I guess there's 3 points I'd like to make on that. Firstly, plateaus are very common. 70% at least, possibly even up to 75% of the planet is covered in sedimentary rock, of which 40% of all of that is a plateau. Even in places like Africa, it's 60% of the entire continent is a plateau. That's the first point that I'd like to make. Secondly, the elevated plateaus seem to lack the evidence of erosion that would have occurred over millions of years. You'd expect to find a far more undulating terrain. And yes, there are some small undulations, but over hundreds of millions of years, these plateaus at times retain an incredible consistency in all of that. The third point is that's despite the fact that in some times the sedimentary layers are not horizontal, they're actually tilted. So they'll actually tilt upwards or in different angles and so on. And so sometimes there's hard rocks tilted up and next to them are soft rocks tilted up, yet the erosion across the top, or the plateauing, is uniform or equivalent. In other words, you would expect over millions of years that the softer rocks would have eroded out, leaving the harder ones as cliff faces and all sorts of things. So I think those 3 lines of evidence point to the fact they're quite young.
Got you. So you're saying that there's a large extent of plateaus, so there's a lot of them, we need to explain them, and some of them are very flat on the top, but some of them are made by tilted beds. So the sedimentary layers have been tilted up and then eroded along the top. Is that correct?
That's what I'm saying, yes. There's more lines of evidence than that when we look at sedimentary at a later time. But the very landform feature itself highlights the fact that they're not millions of years old.
And is that because if they're tilted up like that, then you'd have a soft layer next to a hard layer, next to another soft layer, something like that, and then you should have undulations.
Absolutely.
But you're saying because they're flat, it's showing you that the millions of years is not necessarily a
that those plateaus are recent features, recently created.
So you said, okay, this flood occurred recently. So why do they tell us that a flood's happened? Like what forms the plateau?
Well, it's sedimentary rock. In other words, it's actually primarily made up of flood sediments. In other words, you can have landslide sediments and meteor sediments and all those, but plateaus around the world are made up of flood sediments. And the fact that they a plateau might occupy 10,000 square kilometres. So that's a pretty large flood.
And the way they'd form is by planation, right? It'd be like a planation surface, they're sometimes called. Is that right?
That's correct, yes. Although planation has a slightly broader meaning than that. But yes, you are correct that plateaus are part of planation surfaces.
So speaking of a big flood, the runoff in the flood has caused it to be eroded flat.
Yes, that's why you'll often see one plateau sitting on another plateau, where the one on top is slightly more dissected than the one underneath. It's rather fascinating when you look at those plateau on plateaus.
The second thing you mentioned, Ron, was megavalleys and canyons. Now, can you explain what these are and if they can be explained by a slow erosional process?
Well, megavalleys and canyons are commonly found on either the edge of plateaus or dissecting plateaus, and they're incredibly large valleys compared to the river that's within them.
And so the erosion rate that's happening in those valleys, because you mentioned to me about the steep sides, is there something to do with the steep sides of that tells us about the age of them?
Yes, the fact that they've retained steep sides over lengthy periods of time, often without respect to the rock type or so on. But more importantly, what you don't find in many of these megavalleys is the debris piles, what they call talus slopes, which is all the debris falling down should fall down and be retained at the bottom in these talus slopes. We often don't find them.
And if they'd been old, then we should find them. That's the idea, right?
We should find them because the rivers in those gorges are not sufficient to carry away a lot of that material.
So why don't we find these talus slopes then? You know, if supposedly the Earth's supposed to be millions of years old, these canyons are supposed to be very, very old. Think of the Grand Canyon.
Because the erosion occurred at the time of the receding stage of the flood. As the flood was flowing off the landscape, that flood flow actually removed the debris that it eroded at the time. So as it carved the valley, it took the sediment away with it. What you're left with then is almost a pristine valley.
Great. And so the sediment that is there is just post-flood erosion, which has only been a few thousand years, so it's not as much talus slope as we should expect.
It can often be minor.
So, Ron, do we see valleys being quickly eroded today, or is it a very slow process?
In the last 50 years, I'd say we've seen some considerable erosion on particular events associated with floods or other types of flows. Mount St Helens is a really good example in that during the actual volcanic eruption and so on, there was a lot of deposition and a lot of erosion. But about 2 years later, there was a mud flow in the Mount St Helens region that carved a valley about 30 metres deep within 24 hours. That might seem significant, but then there was an overflow in Oroville Dam in the USA, and that was simply an overflow of a dam spillage. That's all it was. It wasn't a flood. It wasn't a flood at all. But what you saw then was a gorge, basically 300 metres long and about 50 metres deep, was carved into the most incredibly resistant metamorphic rock. And that just happened over a number of days. But then we've got even bigger examples from our looking at the past, and that is particularly in Washington State when we had an ice burst, an ice dam burst, and what happened there was the dammed waters after the ice age poured out across Washington State, tearing the state apart, so that you'd actually get canyons actually created in rapid time, and they would be in the order of 80 kilometres long. Actually, the depth of them would be equivalent to the Empire State Building.
Wow. So you've given us some examples there where canyons have been formed in real time. Real time. I guess the Lake Missoula one is an interpretation because we didn't see it.
It's accepted by Christians and secular scientists. It was long disagreed that it was, but now we recognise that it was a very rapid catastrophic event, and therefore the canyons that were created within days. I mean, we now calculate that the water velocity was moving at about 35 metres per second to carve those valleys.
Yeah, wow.
So that's all the analyses have been done.
And so the Mount St Helens one, for example, will all three examples, does a stream now run in the original cut valley?
A stream now runs in it. So if I was to go in there as a geomorphologist now, without a history, without knowing what happened in the past, and I looked at that, I could interpret that as being a long age gorge or long age mega valley.
Yes, and in fact, wasn't the Lake Missoula flood, the
in Washington
ice dam
State
burst that you were talking about, wasn't that misinterpreted for a number of
It
years?
was misinterpreted for many years.
So why was it misinterpreted?
Because it's based on a foundation of uniformitarianism and long ages. So these are paradigms that are actually throughout science, but particularly in earth science, particularly in geomorphology, is we do not accept or did not accept catastrophism. We accepted only slow processes, constant processes over a long period of time.
Yep. So what you're saying here is we have modern day examples, some that we've actually been there and seen, some that have been well attested to by the geology in the area, of mega valleys, big canyons being cut. But I guess these are much smaller than the ones we see in the rest of the earth. And that's why you're saying these even bigger ones that we see, like the Grand Canyon, etc., that speaks of a much bigger process. It
does. We are not witness to that, of course, but I believe that the evidence we have today that we can, with in these cases they're isolated catastrophic events, and you can create an incredible canyon that is as deep as the Empire State Building, that has to open up a way of thinking that in the past many of these other gorges or mega valleys could have been created by similar process, that of a catastrophic flow.
Yes, and in fact, you saw some of these in your 30 years of research and just thought, well, if we can see this happening today and we know this happens, this is how mega valleys form, why is that not a good explanation for all these other huge mega valleys we see across the world?
Well, you've got, from a researcher's point of view, you've got a scale problem and a difficulty then of accepting catastrophes of that scale.
Yes.
Is a problem. And that comes back to the very foundation of science itself, that it's based on paradigms that are extremely difficult to challenge.
Yes. So by looking outside of the box and seeing the examples that we have on the earth today of big valleys and how they've been cut, and considering that might have happened on a much bigger scale, that can explain a lot of the data we see on the earth. And so that was part of your reasoning of coming to the conclusion of the one worldwide flood.
Yes, it was actually the multiple lines of evidence that brought me to that conclusion. Yeah. This was only one line of evidence.
Yes.
But the point is, when you start bringing all of them together, you get the same pattern.
Great. And so let's talk about the third one, which you said was sedimentary layering. So what does that term mean, sedimentary layering or sedimentary strata?
I guess if you put yourself on the edge of the Grand Canyon and look out across that incredible abyss, what you're going to see are all of these layers that are there. You'll see them almost everywhere you go. In fact, even in a road cutting today, a brand new road cutting, as you drive through it, you're going to see very clear layers of, if it's a sedimentary rock, of sedimentary strata. So these sedimentary strata, that's what I'm referring to. They're layers of sediment that stand out. Some of them are quite beautiful because they have different concentrations of iron or aluminium and give different colours. Even when I was on Fraser Island, the beautiful layers of colour on the sand are just incredible.
Yeah, so and I'm sure most people have seen that in a rock cutting or a rock section, or or you visited the Grand Canyon or something like that, and you'll see these layers of rock, and some of them are alternating colours, but they're often laid down and they're flat on top of one another. Now, what's the normal interpretation? Well, how do scientists say these are formed?
What they argue is that, again, based on the principle of a long period of time, they will argue that silts and clays and sands will come down in small amounts and begin to just layer themselves one on top of the other over long periods of time. And that over that long period of time, it deepens extensively and then eventually forms a rock.
Okay, so
you end up with those layers.
And so would you say there's an issue with that interpretation?
There's a number of problems with that. I guess one of the most important to me is what you would call the flat gaps or paraconformities. And that is that when you see these layers sitting lovely upon each other, one upon another, if we use radiometric dating techniques, we'll often find that a gap might be a period of 10 million years or 20 million years. So if you go into the Grand Canyon and you look at those layers, they will argue that layer above is 10 million years younger than that beneath. Now, the question that's raised in me, and this is my first challenge, is Are you telling me that over 10 million years, that original surface was not eroded or carved up in any way? It's still sitting there beautifully flat for 10,000 square kilometres with another layer on top and then another layer on top. So you have these what we call flat gaps, which can't be explained. Millions of years are missing.
So you're saying it's amazing, first of all, that you've got 10,000 square kilometres of just flat, that surface is not eroded. But on top of that, you're saying, well, if there's a 10 million year gap, or sometimes I think it's even more, in these paraconformities between the next layer, then you're saying, well, if all this time has passed, why is it still flat? Surely it should be eroded and you should have an undulating surface.
Yes, that's my argument, but I'd add to that another element now, and that is the bioturbation argument. And that is whenever you have an exposure of sediment, very rapidly what you're going to see is plant growth, root growth into the actual sediment. You're going to get, say, worms or whatever you've got that could live in the soil will start to burrow and so on. And so you'll get this bioturbation or evidence of organic layer at the top. Now you'll notice that whenever sediment is even shifted in your own backyard and you get a new sediment piled down by the fence, you'll see it very quickly covered in vegetation and all sorts of fauna will get into it and just dig things up and all sorts of things. Now here's the problem, that between each of these gaps that we'll see in the Grand Canyon, in the Great Dividing Range and so on, we see no evidence from one layer to the next of any biological activity or any erosion, as well, as I mentioned earlier. So if you're not seeing biological activity, it says one thing, that sediment sat there by itself for about a day or two before the next sediment layer came down on top of it. Because you can't leave sediment sitting out in the field for more than a couple of days without it already showing signs of turnover on the top layer. Yet as we have one layer on another, we're not seeing the evidence of turnover on the previous layer.
Okay. And how should that look if there had been the bioturbation and the soil forming? How should that look layer on top of layer? Would there just be an in-between layer or something?
Imagine going down to the beach and you've seen some erosion on the beach. So a sand dune has been cut back and you're walking along the beach and you look at that exposure. What you're going to see then is the plants that are growing on the top, you're going to see their root systems hanging down in the actual soil. Okay? So if other sediment was placed on top, those root systems would still be there. They'd be decayed, yes, but you would still find all that evidence of root systems or creatures that have burrowed into the soil and so on. We don't find that. We don't find that evidence.
Okay, interesting. So that's sedimentary layers, that they're flat and we don't see evidence of bioturbation between them. So there hasn't been the time for one layer to form on top of the other, or you're saying it must be a matter of days before they layer on top of each other. And so that fits with a flood model better than a millions of years model.
It would, because it doesn't have to occur day after day. It can occur actually almost instantly. When a flood does occur today, it can put down many layers at once. The argument that puts down one layer at a time is incorrect. Any person who studied floodplains will see multiple layers put down at once. Same with deltas. They can be put down at one time in one event.
Right.
And so these are not distinct layers that represent different events or different periods of time. They can reflect simple stages of what I've called the recessive stage, where the sediment is settling down, just different stages of that process.
Because is it true often I've heard that layering is winter, summer kind of thing? You've got a winter washout or whatever, and that brings one layer. And maybe this is more in the uniformitarian and slow process view. Can you speak into that?
You do get that. There have been studies that have shown that, but they're in areas where a particular system has a very seasonal effect, such as a snow area, where it'll all flush down. Having worked in Finland, I saw it and I was measuring the sediment. The sediment would come as a flush at the first melting in spring. You'd still get other layers coming down later, but you would get distinct layers being created on a seasonal basis. But generally that's only occurring in climate zones where there's a very, let's say, distinct difference between where there's essentially one major flood event. Most other areas, you'll get multiple flood events per year.
Right, I see. So some areas you will get every winter you get a flood, or every summer you get a flood and you get a distinct layer, but the majority of areas you're getting multiple layers per year.
True, but you need to be careful that you're thinking you're getting another layer, because actually in a flood, the flood may remove the previous layer before putting down this year's layer.
Right, yeah, could erode it first.
It could erode the other one first. It does that frequently. Yes. That's why the riverbed doesn't rise year to year. You see the sediment coming down, it's often deposited, but prior to that, during the peak of the flood, it was eroded away.
Yes.
And at the tail of the flood, or the receding, it is deposited. So you look at the river the next day, as many farmers do, and go, no, it hasn't changed at all. But what you don't realise is that during the flood, sediment was removed and new layers were put down.
Yes. Okay, so sometimes if we're looking at the sedimentary record and we're looking at the sedimentary layers and we're thinking this happened in a placid environment, we might be interpreting those layers not as flood layers but as something else. Is what, because it seems like a flood layer makes more sense.
It does. I think there's another element to this, though, and that is that the studies that have been done of these sedimentary strata and sedimentary rocks highlights that their deposition is very characteristic of a high energy environment, not a low energy. So the argument that it's slow process, and that's the interpretation, but when you look at the evidence in the sedimentary rocks, you actually see evidence of braiding and high energy environments, similar to what you see in some of the New Zealand streams today, where there's incredible shifting of materials going on. So I'll go back a step. Every sediment has its own characteristics, has its own fingerprint. And by looking at those sedimentary characteristics, whether it's the medium, the skewness, the kurtosis, all these big words, the point being we can tell the energy of that environment. Surprisingly, many of those sedimentary rocks were high energy environments, not low energy environments. So the very foundation of the argument that it's all low energy sedimentation doesn't really stand these days.
Okay, so Ron, you've said for sedimentary layers, it's the global extent. You get some sedimentary layers that actually just cover continents, I've heard. So you've got some sedimentary layers that cover very large extent. They're flat, they're not eroded, there's no bioturbation. So all of these things about sedimentary layers, you're saying, points better to a global flood. So Ron, I want to ask you the next one, number 4, water gaps. So first of all, can you tell us what is a water gap?
Well, a water gap is a river that cuts through a mountain range as though it shouldn't be there.
Yep.
As though it shouldn't be there.
How does it do that?
Oh, let me give you an example first. I've just been to Alice Springs recently, and the Finke River and others like Ellery Creek, which is only a creek, cut through numerous mountain ranges, not one, multiple. And what is fascinating with the river that shouldn't be there is that those mountain ranges, one can be tilted one way and one is tilted another way, yet the river just flows through both of them as though with complete indifference, when the actual height difference would have said that the river would have flown around them. It's only about a 10-metre difference in height. They could have flown around those mountain ranges, but they didn't. They flow through them. And so that's a water gap, is a river cutting through a mountain with absolute indifference.
So water would usually take the easiest route, the lowest route. It wouldn't try and cut through the mountain if it's only a small stream.
Yes.
But for some reason, this small stream has managed to cut through the mountain and it didn't flow around it.
If you assume it's a small stream, yes.
Okay, yeah. Yes. So you're saying it has a different past. So what's the explanation? How do these water gaps, they sound quite mysterious. What's the best explanation for how they form?
Well, they're more than mysterious. They're actually quite attractive as well.
Okay.
Very popular with tourists. The arguments for water gaps today are very weak. Yep. One argument is that the river was on top of a high area and then just slowly cut down, leaving mountain ranges. Another one is that the river is at almost sea level today, but the mountains have risen up slowly and the river has cut down while the mountains were rising.
But how would a small river do that?
That's the question, absolutely. Yeah. And so it has led scientists today to conclude that their arguments really have no basis whatsoever, because what you're doing is you're inventing mountain ranges. You're inventing processes over millions of years when you were not there to see it. You have no evidence of it. And so it's just a way of using uniformitarianism as your paradigm, because you're not going to invoke something catastrophic. On the other hand, I'm going to argue that again, these are another form of the receding waters coming off plateaus, carving, in one case they're carving mega valleys and gorges, in this case they're carving much narrower ranges through narrow gorges, but they're water gaps because they're so small as they carve through the landscape completely. But again, yes, the valley, like the Finke River, still has a gorge-like look about it, but is much smaller.
Yeah, okay. So it seems like water gaps are better explained by a big flood with runoff.
Well, when you particularly look at parts of the world, in some places, the USA or Australia, where it's extremely dry, and the likelihood of a decent flood is quite low, you're going to need an awfully long time for rivers like the Finke River to carve through all those mountains. Yes. Which is a rather interesting publication has come out by the Northern Territory Geological Society, or Association, I think, of the government, suggesting that because of this unusual feature, the Finke River must be the oldest river in the world.
Oh, so how does that work in their interpretation?
Because it took so long to cut through all those mountains.
Oh, I see. So maybe the mountains have rose very slowly.
That's what they're arguing.
And the small rivers just...
In a desert environment, it must have been an extremely slow process.
Yeah, interesting. So a much better explanation being?
Simply the runoff from the receding stage of a global flood. Why do I say global again? Because those water gaps are like gorges, are like mega valleys. They are found worldwide. If you go to, for example, Iran, it is riddled with water gaps. If you go to the Himalayas, water gaps all through there. USA, Australia. You go into Central Australia. I've been trying to document how many there are, and they're everywhere. The Flinders Ranges. So given that they are found all around the world, in South Africa as well, I think you have to look at a common denominator, not a case-by-case approach.
So that's really interesting about water gaps and how they seem to be much better explained by a global flood. Now, the fifth line of evidence that you mentioned was underfit rivers. Now, what is an underfit river to start with?
An underfit river is something I've studied my entire career. It was actually my first thesis as well. And the underfit river actually refers to the river that may be in the mega valley, but may be elsewhere as well. In other words, the river does not look as though it belongs there. It's inconsistent with the size of the valley again. But we're now talking about the river itself. That's what underfit refers to. Now, people have studied that for over 100 years, trying to explain this. It was an unusual feature, and in case studies all around the world, they've come up with every explanation from past climatic change, past floods, unusual bedload in the channel, cohesive banks, glaciers. Everyone comes up with a different explanation of this. The fascinating thing that was found, though, is that they are now recognised in every continent, in every climatic zone around the world. So, for example, in France now, you will see that 50%, roughly, of the rivers in France are actually underfit. They don't look as though they belong there. So an underfit river, in simple terms, shouldn't be there. It's in the wrong place.
Is what you're saying, Ron, that underfit rivers are not only small rivers found in deep canyons, as we talked about slightly earlier, but they can be a river that doesn't fit in the context for some other reason as well? I mean, what could the other reason be?
Correct. You will actually see it across eastern Australia, flowing inland, the Murray, Murrumbidgee. You'll find that many of the tributaries are underfit, even in that tail end of the plateau. So you'll find underfit rivers everywhere, effectively. And I think the biggest problem with underfit rivers, when we talk about it seems not to belong in the valley, I really do mean it doesn't belong in that valley, because the discharge or the flood flows that are expected to have created that environment have been calculated to be 50 to 60 times larger than current flows. 50 to 60 times larger. Not a slight increase. In other words, the flood flow going down those rivers had to be 50 times larger than what you see today.
And do we, in an extreme flood example, do those rivers, what kind of discharge do you see at the height of a current day flood?
Well, a current day flood, even the worst floods, would only be 40%. I'm talking about 40% of the existing flow, not 50 times larger.
Wow.
The magnitude that's been calculated that these rivers should have had of the floods is just phenomenal. And it's caused incredible chaos in the geomorphic world.
But I see, like, I've got a river near me, and sometimes that's very small, and I'm sure it goes to 2 or 3 times the size sometimes in a flood. So
no, what I'm talking about there is the flood.
Yeah.
The peak flows will go 50 times larger than the current peak floods. You're not comparing a low flow to a flood. You're comparing the peak flow today to what they say was the peak flow at some time in the past. It's 50 times bigger than the current peak flows.
Okay, that makes sense. So
yes, it's called a bankful stage.
So the highest flood stage that you will see today, 50 times larger than that.
50 times larger.
Wow.
That is impossible from a meteorologic point of view. Because in a catchment of certain size, you cannot generate that amount of rainfall. Can't be done.
Right.
Because we have limits in frequency, duration, and so on of rainfall. We cannot generate them today. That's why it's all gone very quiet in the underfit world of explanation.
Interesting. So just by rainfall alone, you cannot get the 50 to 60 times peak flood flow. And you mentioned that people have got different ideas about processes, and one that had came to my mind, and we did talk about it earlier, but let's talk about it again, is could have that, you've got a little stream in an underfit in a big canyon, could have the canyon not been cut by a glacier and then the stream be what's left over? Why is that not a possible explanation?
There's often a misunderstanding that the Ice Age covered the entire Earth. Yep. It did not. Yep. In fact, it covered, yes, parts of Siberia. It came down over parts of England, parts of Europe, obviously Finland. It barely touched Australia or other major continents at all. So the Ice Age had an impact and glaciers had an impact in those areas. But the point is, the underfit rivers and the mega valleys and the canyons and all the rest of it are found in every climatic environment on the planet, whether it's tropical, temperate, arid, or Arctic. So the argument that glaciers are responsible doesn't hold ground. Doesn't fit for all.
Okay, that's great. Thanks, Ron. So we've covered water gaps, steep-sided valleys, big gorges. We talked about underfit rivers, plateaus, and sedimentary layers. Now, these were the things that you'd seen over the 30 years of research that some of the things that drew you to the conclusion that there was a global flood in the past. Now, can you just summarize, do these things link together in some way to also give you the history of the Earth?
The reason I chose those 5 is that they are all global. They are found across all terrains, all climatic zones around the world. So in other words, there's a commonality here in process, there's a commonality here in origin. The problem with much of science, and it's not just geomorphology or earth science where I work, but much of science is based on a case-by-case model of research. In other words, I'll look at one underfit valley and I will try to interpret that, as I said earlier, and then every person comes up with a different interpretation. It's only by comparing them across the globe and across different environments do you then start to see commonality in them. A case-by-case basis is a great way to start. But what we have to do is combine those studies and look at it at another level, at a different level, a global level, and look at the commonality, not the differences. There's incredible commonality when you do that.
Great, thanks, Ron. So we've got some things to think about here. Is there another way to explain them, or is that the best way to explain them? It seems like your professional experience and your professional opinion is that water gaps, steep-sided valleys, underfit rivers, plateaus, and sedimentary layers show that there was a worldwide flood in the not-so-distant past. So this is a great thing for people to think about, whether non-Christian or Christian, is like, how do we explain the geologic evidence on the Earth? How do we explain these things? Is the best explanation that there was a worldwide flood? And if it was, then that kind of points to the Bible's history as maybe being accurate. And I think that's what you found in your journey. Is that correct?
That's correct. And I think the best way to summarize that is to bring those 5 together. And if I could almost sort of try to put in your mind a picture that as I traveled the world, I kept seeing consistent landscapes and a consistency in catastrophism. In other words, the world is very much made up of plateaus, significant number of plateaus with relatively uniform surfaces with some slight undulation. But around the world, those plateaus then are dissected by megavalleys and canyons. As the water was running off the plateaus, it became more concentrated, as water does. The more it flows, the more it becomes concentrated into channels. So what we see today as a river channel, what you were seeing then was a massive channel, massive gorges being created and so on. At the same time then, as the water is tailing off, you will get then the formation of other features, smaller features that respond to the geologic turns that are going on, the geologic fine-tuning that's going on, and that's water gaps and underfit rivers and so on. So in other words, all of those features, what you see today when you go for a bit of a trip, driving in a car or in a plane, you're going to see plateaus, dissected, steep cliffs, canyons, and then you're going to see other features attached to that. And I've only listed 2 of them. There are many other features attached to that. The point is they're an incredible global uniformity, if you like. If I put it that way, it's the wrong word, but there's an incredible similarity across the world. I think the one disappointing thing in understanding all that is next time you go on a travel, you're going to go, oh, look, there's evidence of a great flood, isn't there? There's a plateau there and there's a gorge there.
So you've ruined people's holidays in a very good way, I would imagine.
My wife says that.
So Ron, thank you so much for your time and sharing your expertise with us and giving us the reasons that you saw for a global flood and even describing some of these geomorphological terms to us. Now, if people want to find out more, if they want to look at some of the research behind some of the things you're saying, where can they go to get that information?
We at Creation Ministries International have a website, creation.com, of which there are over 15,000 articles today for you to explore, download, read, share, pass them on. Our purpose is to simply link and feed. In other words, why do we put all that online? Why do we speak at churches? Why do we speak with youth groups? It's to link with you in the first place, to share that with you, and to feed you then, because we have this incredible array of material, whether it's resources, clips, and so on, and particularly articles on the website for you to grow and to learn more. We provide all of that. More importantly, I think, from a, let's say, my perspective, we link and feed with you. I would really encourage you to link and feed with others using our materials, because wherever I have given our magazine, or I have given a CMI, Creation Ministries International book, to other people, it has impacted them. And as you know, I came from an atheistic family, as did my wife, and today about 50% of those families, both families, are now Christians because they received Creation Ministries International material, got access to the website because they could, and they were encouraged, read the magazine, read books, and it is just an incredible journey you can take others through as well. So if you want some details on any topic, not just today's topic, but anything to do with evolution, space, biology, the resources are incredible.
Gosh, so the resources of Creation Ministries International has really impacted you and your family. And so if other people want to get that information, the website again was creation.com.
Correct.
Thanks very much, Ron, for your time.
Thank you, Scott.